Hello everyone, I am Dr. Venkateswararao, Assistant Professor, PG Department of Chemistry, Sri Vayan College, Narsapur. In the last video, that is mole concept part 2 problems, we had gone through the problems based on the mole concept and we calculated number of moles and number of gram atoms and also number of atoms of each element in a molecule. And we stopped at solving the problem, that is weight of O2 gas liberated by heating 2.45 grams of potassium chlorate KClO3. This is the problem where we stopped the last lecture, that is last video, and the problem is weight of O2 gas liberated by heating 2.45 grams of KClO3. To solve this problem, we should know the chemical process. What is that chemical process? KClO3 upon heating liberates oxygen gas, and we should calculate the weight of that oxygen gas liberated. So, to solve this problem, we should represent that chemical process by a chemical reaction. That is, we can represent the chemical process, that is heating of potassium chlorate, by a chemical reaction as KClO3 gives rise to KCl plus O2 gas. This is the chemical reaction for that chemical process. So, potassium chlorate upon heating that liberates oxygen gas as well as to form potassium chloride. And what asked in the problem? Weight of O2 gas liberated in this by heating 2.45 grams of potassium chlorate. So, we can represent the chemical process by this chemical reaction, and already I told you that every chemical reaction should follow the law of conservation of mass, law of definite proportions, law of multiple proportions. Therefore, every chemical reaction primarily it should follow the law of conservation of mass. When we look at this chemical reaction, we came to know that usually we can understand that this chemical reaction should not follow the law of conservation of mass. How can I say that that chemical reaction does not follow the law of conservation of mass? Simple, very simple. Law of conservation of mass means the weight of reactants is equal to weight of products. For example, KClO3, its molecular weight potassium 39, chlorine 35.5 and oxygen 16, 316 is 48. Together molecular weight of potassium chlorate is 122.5. This 122.5 grams should, and this weight of potassium chlorate is the left hand weight is 122.5 grams and the right hand weight is potassium 39 and it's 35.5, total 74.5 plus oxygen, one oxygen 16, two oxygens 32. Here the left hand mass, that is left hand side mass, is not equal to right hand mass, that is mass of the reactants does not equal to mass of the products. Then we can simply say that that reaction did not follow the law of conservation of mass. Now we should, to solve this problem, we should balance this chemical reaction to follow the law of conservation of mass. How can we balance the chemical reaction to follow law of conservation of mass? We can balance the any chemical reaction by following stoichiometry rules. What is this stoichiometry? The term stoichiometry derived from a Greek word which means to measure an element. That is, stoichiometry is a quantitative aspect which deals with mass and volume relations among reactants and products in a chemical reaction. Usually we balance the chemical reactions by following stoichiometry rules. We will see the laws of stoichiometry and principles of stoichiometry in a separate video. To solve this problem, we should balance the chemical reaction. How can we balance the chemical reaction? By trial and error method. By trial and error method, we can balance the chemical reaction. Here mass is law, this reaction does not obeys the law of conservation of mass, and if you observe this chemical reaction with your naked eye, the number of oxygens here, that is reactants side is 3 oxygens, but number of oxygens on the product side is 2. So oxygens are not balanced. And of course potassium, one potassium is there and one potassium there. One chlorine is here and one chlorine is there. So potassium, chlorine are balanced in the chemical reaction, but the number of oxygen atoms or oxygen molecules are not balanced. We can balance the chemical reaction by trial and error method. Here 1 mole of potassium chlorate dissociates into KCl plus O2, but this reaction is not balanced. We can balance the chemical reaction by trial and error method. For example, if you increase the number of moles of potassium chlorate to 2 moles, then we can get 2 KCl and 3 O2. Now this chemical reaction is balanced chemical reaction, because oxygen 236 and 326 equal, potassium 2 KCl 2 KCl. So this chemical reaction is balanced. Now we solve the problem. What is that problem? Weight of O2 gas liberated by heating 2.45 grams of KClO3. So here you can see the 2 moles of potassium chlorate liberates 3 moles of oxygen gas. That is, 2 moles of potassium chlorate liberates 3 moles of oxygen gas. Then 1 mole of potassium chlorate liberates, we can simply 3/2 mole, 3/2. We can solve this by cross multiplying, but we don't know how many number of moles involved in this particular process. So we have to calculate the number of moles of potassium chlorate, but we know the weight of potassium chlorate, that is 2.45. We can calculate the number of moles by the formula weight by gram molecular weight. By dividing the weight of that particular substance by its molecular weight, we can get the number of moles, that is 2.45. Already 1 mole is equal to weight by gram molecular weight. So we can calculate the number of moles, 2.45 by 122.5, that is 0.02 moles of potassium chlorate involved in this process. Therefore, 2 moles of potassium chlorate liberates 3 moles of oxygen gas, then 0.02 moles of potassium chlorate liberates how many moles of oxygen gas? Sorry, how many moles of potassium chlorate? Okay, we can simply solve this problem by 3/2 into 0.02. That is, we can solve this, when we solve this mathematical equation, we get 0.03 moles. 0.03 moles. So 0.02 moles of potassium chlorate liberates 0.03 moles of oxygen gas. But what they asked? They asked to calculate the weight of oxygen gas. So weight of 1 mole of oxygen gas or O2 gas weighs 32 grams. So that is 1 mole. But 0.03 moles of O2 weighs 0.03 into 32 grams. That is 0.03 moles of O2 weighs 0.03 into 32. We can write this 3/100 into 32, that is 96/100, that is equal to 0.96 grams. Therefore, the weight of O2 gas that liberated by heating 2.45 grams of potassium chlorate is 0.96 grams. In this way, we can calculate this, we can solve this problem. Okay. Now, I shall try to make an attempt to explain the concept of equivalent weight. What is this equivalent weight? Equivalent weight. Before we are going to discuss the concept of equivalent weight, first of all, we should know what is the reason behind to introduce this concept. Why this concept is introduced? Already we know chemical substances are being quantified in moles. Okay, so we can quantify the chemical substances by moles, even though the concept of equivalent weight is introduced. So we should know the reason behind to introduce the concept of equivalent weight. The reason is why this equivalent weight is introduced is for comparing the reacting weights of substances in a chemical reaction. Chemists introduced the concept of equivalent weight. I repeat, for comparing the reacting weights of chemical substances participating in a chemical reaction, chemists introduced the concept of equivalent weight. So, what is equivalent weight? Equivalent weight is defined as number of parts by mass of a substance which combines with or displaces directly or indirectly 1.008 parts by mass of hydrogen, 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. I repeat, equivalent weight is defined as number of parts by mass of a substance which combines with or displaces directly or indirectly 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. It is somewhat difficult to understand this definition, but we can understand this concept of equivalent weight by example. Okay, now first I shall calculate the equivalent weight of an element. Equivalent weight of an element. Usually, equivalent weight of an element can be calculated by using the formula, that is equivalent weight of element is equal to atomic weight of that element by its valency. For example, if you take the oxygen element, if you take the oxygen exists as O2 and its atomic weight is 16. one oxygen atomic weight is 16 and its valency is 2. So 16 by 2 is equal to 8. 8 is the equivalent weight of element oxygen. Simple. Divide the atomic weight of that element by its valency. Then you can get the equivalent weight of that element. Let us go for another example. Calcium. Calcium, its atomic weight is 40 and its valency is 2, that is 20. 20 is the equivalent weight of calcium. Okay. So in this way we can calculate the equivalent weight of an element. But in chemical reactions, compounds undergo in chemical reactions. How can you calculate the equivalent weights of compounds? Or how can you calculate the equivalent weight of element in a compound? Let us see another example. That is, let us take another example, that is copper. Copper forms two oxides, that is, copper forms two oxides that are cuprous oxide and cupric oxide. Cu2O and CuO. Now we shall calculate the equivalent weight of copper in the compound, that is cuprous oxide. We have formula. If you want to get the equivalent weight of any element or element, then you should divide its atomic weight by its valency. Already I told you, oxygen, 16 grams of oxygen contains 2 equivalents. 16 grams of oxygen contains 2 equivalents. Now we shall calculate the equivalent weight of copper in this cuprous oxide. So in this 2 coppers, 2 into 63.5 by its valency, it combines with the 16 grams of oxygen, that means that contains 2 equivalents, because its valency is Cu plus 2, that can, that's where copper valency is 2. Then we can get the equivalent weight of copper in cuprous oxide is 63.5. Now that means 2 equivalents of copper reacts with 2 equivalents of oxygen. Okay, 2 equivalents. 1 equivalent of copper is, so 2 into 63.5 by 2 is equal to 63.5. Now we shall calculate the equivalent weight of copper in CuO, cupric oxide. Cupric oxide, copper only 1 equivalent, copper atomic weight 63.5. Okay, it combines with the 2 equivalents of oxygen. It combines with the 2 equivalents of oxygen. So here the element copper has atomic weight 63.5, but it combines with the 2 equivalents of oxygen. that is 63.5 by 2 is equal to 31.5. Of course, with these examples also, you may feel difficulty to understand the concept of equivalent weight. Now, we shall go for another example, that is H2SO4 plus NaOH gives rise to NaHSO4 plus H2O. Next, H2SO4 combines with 2 moles of NaOH, forms sodium sulfate plus 2H2O. This is sodium bisulfate and this is sodium sulfate. Okay. So, if you see this example with your naked eye, that is, if you observe this reaction keenly, 40 grams of sodium hydroxide. So, 1 mole of sodium hydroxide, 1 mole of sodium hydroxide or 40 grams of sodium hydroxide, that replaces 1 hydrogen from H2SO4 to form NaHSO4, sodium bisulfate, plus 1 mole of H2O. But 2 into 40, 80 grams of sodium hydroxide displaces 2 hydrogens from H2SO4 to form sodium sulfate. Already I told you, equivalent weight of a substance, number of parts by mass of a substance which combines with or displaces in the cuprous oxide and cupric oxide, that combines, oxygen combines with copper. Here 40 grams of sodium hydroxide displaces. Okay, you got the point? So, equivalent weight of a substance is the weight by which combines with or displaces 1.008 parts by mass of hydrogen or 35.5 parts by mass of chlorine or 8 parts by mass of oxygen. So, equivalent weight of sodium hydroxide. So, let us calculate the equivalent weight of sodium hydroxide. Sodium hydroxide is a base. So, 40 grams of sodium hydroxide displaces 1 hydrogen, to form NaHSO4. So, equivalent weight of NaOH is equal to its molecular weight 40 by how many hydrogens it replaces? Only 1 hydrogen. Then we can, that replaces means it is that valency. Sorry, valency is especially used for elements. Okay, so that displaces only 1 hydrogen, right? Next, for example, 2 into 40, 80 grams of H2SO4, 80 grams of sodium hydroxide displaces 2 hydrogens. In this case, 2 into 40, 80 by it, how many hydrogens it displaces? 2. 2 into 80 by, 2 into 40 by 2. 2 get cancelled. Again its equivalent weight is 40. Okay, let us see the reverse case. H2SO4, 98 grams of H2SO4 displaces one OH group from sodium hydroxide to form one mole H2O. So, equivalent weight of H2SO4 98 by, it displaces only one OH group. So, that is equivalent weight is 98. But same 98 grams of H2SO4 displaces two OH groups to form two water molecules. In this case, we should write 2 here, that is 49. So, 98 grams of H2SO4 contains two equivalents. Usually, we say the equivalent weight of H2SO4 is 49 because 98 by 2, because in the H2SO4 the number of replaceable hydrogens are 2. That is why we can write 98 by 2 is equal to 49. But for example, let us see the another case. Equivalent weight of NaOH. NaOH displaces one hydrogen. So, base replaces one hydrogen, acidic hydrogen. That is why we used to write the formula equivalent weight of base by the formula molecular weight by acidity. Molecular weight by acidity. Molecular weight by acidity is the formula to calculate the equivalent weight of bases. Next, equivalent weight of acids, that can be calculated by molecular weight by basicity. Basicity, because basicity, why basicity? Why basicity? 40 grams of NaOH, it displaces one, base replaces hydrogen. That is why that is basicity. So, basicity is a number of replaceable hydrogens and acidity is a number of replaceable OH groups. So, that is why we used to write the formula equivalent weight of acids is equal to molecular weight by basicity. Basicity means number of replaceable hydrogens. Of course, compound may contain several number of hydrogens, but all the hydrogens are not replaceable hydrogens. You can see the examples. Okay, H2SO4, H3SO4, H3PO3, H3PO4, HNO3. Okay, so when we see the number of examples, okay, we may find number of hydrogens in a molecule, but all the hydrogens are not replaceable hydrogens. So, basicity is number of replaceable hydrogens and acidity is number of replaceable OH groups. Next, let us see another example. Therefore, so equivalent weight is number of parts by mass of a substance that combines with, here oxygen combines with copper, that combines with or it displaces, here NaOH displaces one hydrogen, 1 mole of NaOH displaces one hydrogen, 2 moles of NaOH displaces 2 hydrogens. So, it combines with or displaces 1.008 parts by mass of hydrogen, 35.5 parts by mass of chlorine and 8 parts by mass of oxygen. Okay, let us go for another example. HCl plus NaOH gives rise to NaCl plus H2. Here 1 mole of NaOH replaces 1 hydrogen, so equivalent weight is molecular weight by 1, and here HCl replaces 1 OH group and forms 1 water molecule. So its equivalent weight is molecular weight by acidity. So base acidity, acid basicity. Okay, it forms sodium chloride. Sodium chloride is a salt. Then how can we calculate the equivalent weights of salts? Equivalent weight of salt NaCl, which is also calculated by using the formula molecular weight by total charge on cations or total charge on cations or anions. But usually we find the formula weight in case of salts. We could not find molecular weight in case of salts, because salt, for example, if you take sodium chloride, in its structure, sodium being surrounded by 6 chlorine atoms and chlorine is being surrounded by 6 sodium atoms. That is why sodium chloride that is not exist as a NaCl molecule. In its structure, sodium is surrounded by 6 chlorine atoms and chlorine is surrounded by 6 sodium atoms. That is why we used to write formula weight. So formula weight for equivalent weight of sodium chloride or equivalent weight of salts, we should write formula weight by total charge on cations or anions. Okay, so sodium chloride, that is 58.5, I think 58.5 by charge on the cation Na plus 1 positive charge, then we can divide with 1. Next, another example, equivalent weight of K2SO4 Al2SO4 thrice 24H2. Okay, this is also a salt, okay, alum. We can calculate this, its equivalent weight by dividing molecular weight of this salt by total charge on cations or total charge on anions. For example, we calculate the charge on positive ions, cations. Potassium having the positive charge plus 1, so 2 potassiums plus 2, and Al2, 1 Al aluminum carries plus 3, that is 2 3s 6, 6 plus 2 8. So molecular weight by 8. Of course, we can calculate SO4 total charge on the anions. SO4 carries minus 2 charge, 3 to 6, and again we have SO4 minus ion and 3 to 6, and K2SO4 twice, and another wrong. This is wrong. Okay, we can write, so we can write 8 as a charge, total charge on cation and total charge on anion. In this way, we can calculate the equivalent weight of acids, bases, salts, and all these comes under the category of non-redox changes. Non-redox changes. So acids, bases, salts, all these are under the category of non-redox changes. Now we shall see the redox changes. How can we calculate the equivalent weight for redox changes? For redox changes, equivalent weight is defined as number of moles of electrons transferred to 1 mole of oxidant or released from 1 mole of reductant is known as equivalent weight of oxidant or reductant. Okay. So I repeat, number of moles of electrons transferred to 1 mole of oxidant or released from 1 mole of number of electrons released from 1 mole of reductant. So by definition you may feel difficulty to calculate the equivalent weight of oxidants and reductants. In this context, I shall try to explain the difference between oxidation and oxidant, oxidizing agent, reduction and reducing agent. We know oxidation means loss of electrons. Reduction is gain of electrons. But oxidant or oxidizing agent, okay, reductant or reducing agent, okay. So oxidation is loss of electrons, gain of electrons is known as reduction, but oxidant or oxidizing agent, that itself gain electrons, okay. Okay, you should discriminate the difference. That is, oxidation means loss of electrons, but oxidizing agent, that itself gain electrons. Reduction, gain of electrons is called reduction, but reducing agent, that itself losses electrons. Okay, I hope you catch the difference between oxidation and oxidant, reduction and reductant. Okay, now we shall calculate the equivalent weight of oxidant. Okay, let us take one oxidizing agent and one reducing agent. We all know KMnO4 is a good oxidizing agent. So oxidizing agent, KMnO4 acts as oxidizing agent in the acidic medium. Okay, so KMnO4 8 H plus 5 electrons gives rise to Mn plus 2 byproduct. Okay, here we can write KMnO4 or MnO4 minus. How can we calculate equivalent weight of oxidizing agent? It is very simple, very simple. Equivalent weight of oxidant is equal to, again, molecular weight by number of electrons transferred. How can we calculate the number of electrons transferred? We can calculate the number of electrons with the oxidation state changes or oxidation state change. For example, MnO4. What is the oxidation? And we can calculate the oxidation state of manganese in this MnO4 as, let us oxidation number of Mn be X plus oxygen, it has valency 2 minus 2, that is 4 minus 2, that is 8 minus 8 is equal to, we have to equal this equation to its charge, whatever the charge here. Okay, we should equate this equation to its charge, that is minus 1. So x equal to minus 1 plus 8, that is equal to plus 7. So in MnO4 its oxidation state is plus 7, manganese oxidation state is plus 7. Okay, and it changes to plus 2. Okay, so plus 7 to plus 2. Here gain of electrons takes place. Already I told you, oxidizing agent that itself gain electrons. It gains 5 electrons for 1 mole. For 1 mole of MnO4 it gains 5 electrons. Then we can divide by 5. Its molecular weight is 159, I think. 158 is molecular weight of KMnO4 by 5. You can get the value of equivalent weight of KMnO4, right? So in this way we can calculate the equivalent weight of oxidizing agent. Now let us see equivalent weight of reducing agent. The best example for reducing agent is ferrous sulfate. Okay, ferrous sulfate. Just ferrous sulfate. Ferrous sulfate is good reducing agent. Okay, so FeSO4, 2FeSO4 plus SO4 minus 2 gives rise to Fe2SO4 thrice. Fe2SO4 thrice. Here FeSO4 is a reducing agent. We should calculate the number of electrons transferred. Equivalent weight of FeSO4 reducing agent, reductant is equal to molecular weight by number of electrons transferred per mole. Okay, so FeSO4, how can we calculate the number of electrons transferred by oxidation state change. So, FeSO4, in FeSO4 it is here let us say oxidation state of iron is X, thus SO4 minus 2, that is minus 2 is equal to 0. Here there is no charge, that is why I am equating to 0. So, X equal to plus 2, and here 2x minus 3 to 6 is equal to 0, 2x equal to 6 and x equal to 6 by 2 and x equal to plus 3. So, oxidation state changes from plus 2 to plus 3. So, that means plus 2 to plus 3 means it lost 1 electron, it loses 1 electron. Already I told you reducing agent, reduction means gain of electrons, reducing agent that itself loss electrons. So, plus 2, this oxidation state changes from plus 2 to plus 3, that means it lost 1 electron, it loses 1 electron. So, then we can write 1 for 1 mole. Okay. So, in this way we can calculate the equivalent weights of acids, bases, salts, oxidizing agents and reducing agents. Okay. So, in the next video we shall discuss mole concept and equivalent concept together. Thank you.